NPL is known as the National Measurement Institute of India. Every country has having only one such type of institutes. Our work is to maintain all the national standards and doing research in maintaining and developing new standards for India. So basically, we are in the development of new national standards of measurement and to realize the SI unit based on international system. And we are doing research in physics and related interdisciplinary areas, and we are assisting industries to help to help in increasing the economy of India. Basically, CSR NPL is the National Meteorology Institute of India by the Act of Parliament, and it is the member of Meter Convention and a signatory of International Bureau of Weights and Measure, France. NPL has responsibility for maintaining the national standards of measurements, traceability of measurements through bilateral international key comparisons. Basically, whatever measurement you are doing in your lab, at your home, at any places, whatever type of measurement you are doing, that will be directly or indirectly traceable to NPL. If you are measuring a 1 meter of cloth, or you can say anything, so that meter will be directly or indirectly traceable to NPL. Basically, right now we are having 7 SI units like meter, kilogram, second, ampere, Kelvin, mole, and candela. So earlier, in earlier SI system, we are using physical artifact for measuring for maintaining these SI units. Like for meter, there was a platinum rhodium rod of 1 meter. With the help of that rod, we are defining the meter. Similarly, for kilogram, we are having one artifact. But in 2019, on 20th May 2019, these SI units have been redefined using fundamental physical constant, because these physical artifacts are unstable and there is a chance of change of its dimension because of environmental conditions. So there is a need for universal, stable and precise standards. So on 20th May 2019, SI units redefined using fundamental physical constants, because physical constants will never change. The main benefit of going towards physical constants, there is no reliance on physical objects, so there is no chance of any change in the standard. So based on the 2019 redefinition, now second is defined with the help of hyperfine frequency of cesium, that is 9192631770 hertz, and meter is defined using the speed of light. Similarly, kilogram has been redefined using Planck's constant, and ampere with the help of elementary charge of electron, Kelvin with the help of Boltzmann constant, and mole with the help of Avogadro constant, and similarly candela with luminous efficacy. So now major changes: the kilogram no longer based on the international prototype of the kilogram, that is a physical artifact. Now kilogram is defined with the help of Planck's constants. Planck's constants will never change. If environmental conditions are changing, there will be no effect on Planck's constant. Similarly, now ampere no longer defined by the force between two conductors. It is defined with the help of elementary charge. Kelvin, there is no relation with now triple point of water. Now Kelvin is defined with the help of Boltzmann constant. Similarly, mole no longer linked to the mass of carbon-12. Now it is defined with the help of Avogadro constant. So advantage of this redefinition is constants are invariant. These are applicable under all environmental conditions, and these are provide you very precise measurement which supports advanced technology and research, and these are adaptable to scientific progress. So NPL, if I am talking about NPL, NPL is basically realizing national standards of measurement. So NPL is having right now 236 CMCs. CMC means calibration and measurement capability. Every country is having some CMC, and that CMC is maintained in the international database. The ranking of that country is defined with the help of these CMCs. So right now India is having 236 CMCs, but in coming year it is increasing. By the end of next year, it will cross around 280 CMCs, and we have participated in more than 168 international or bilateral key comparison. So what is basically bilateral or international comparison? So international comparison, basically we are sending one artifact to n number of countries. Every country is doing some measurement, and that after that the analysis of that measurement is done based on the actual results of that artifacts. So right now NPL is having representations in CGPM, BIPM, OIML, CCs, TCs, APMP and ISO, ILAC, and it is basically establishing primary and secondary standards of measurement, and NPL is the signatory of meter convention and CIPM mutual recognition arrangement, and we are actively participating in various intercomparison and implementation of effective quality management system. We are every month we are registering and publishing more and more CMCs in key comparison database of BIPM. BIPM basically Bureau of International Weights and Measures, France, or providing traceability to the country through our established standards. So basically we are maintaining all the SI units and their derived units. You can see there are, just one second, I'm putting my pointer. These are the SI units and these are all the derived units. So we are maintaining all the SI units and their derived units. So if you are seeing the national or international quality infrastructure, so NPL NMI of the any NMI of any country comes at the top most. Then it comes to Bureau of Indian Standards, then Quality Council of India, then Department of Consumer Affairs. Then there are various certification bodies, hospitals, testing and calibration laboratories, and legal metrology. If you are talking about international quality infrastructure, then it comes to BIPM, Bureau of Weights and Measures, Indian Standard Organization, ISO, IEC, ILAC, IF, and OIML. So this is the basically national and international quality infrastructure. And at NPL, we are serving government, semi-government, private industries, even SAARC nations. We are providing support. If we are talking about government, we are providing supports all the PSUs, all the defense and strategic sectors, BIS and other calibration bodies also. So now I have a small video which will reflect you what NPL is doing since 1947. This is not a long video, it is only I think 1 or 2 minutes. So this was about NPL. So you have seen in this video that uh, our Prime Minister is seeing the Constitution of India. So that is the basically original Constitution of handwritten Constitution of India, which is being preserved by the NPL.
Excuse me, sir.
Yes, madam.
Sir, I think your first slide is only showing to me, presented by Dr. Anshul Varshney.
Just one sec, ma'am. Now,
No, sir.
Sir, your screen is visible, sir, to us. I
Sir,
think ma'am
slides
has
are
a
visible.
network
Why
issues.
solar energy? Some problem with ma'am.
okay.
Okay,
Yes,
okay.
Why
definitely.
solar energy? Slides are changing, sir.
Okay,
Some
ma'am.
problem with that, madam.
Okay,
Okay.
okay.
So I am continuing. So as you have seen, the original handwritten Constitution of India is preserved by NPL, and you have seen that you have used that whenever you are casting your vote, that person is putting some ink on your finger. That ink basically has been developed by NPL, and later on that technology has been transferred to Mesur paints. And NPL is the official timekeeper of India. We are responsible for generating Indian Standard Time for our country. And we are doing research in the materials also. In you can say carbon or carbon nano tubes. We are doing researches also. The bar head of earlier Agni missile was developed at NPL. So this is all about NPL, what NPL is doing. So now I'm starting my presentation on basically on solar water pumping systems. So what is the need of solar energy? Why solar energy is required? So right now, day by day, there is an increase in the cost of conventional energy sources, and they are responsible for increasing the pollution also. And however, solar photovoltaic is pollution free and it is known as green energy. It is available unlimited in quantity. And right now, as Dr. Arun already told, NPL is doing great research in solar cells. So in the research of solar cells, we are responsible for increasing the efficiency of solar panels, and there are several encouraging government policies, which Dr. Arun already explained. Because of that, solar energy has become a prominent source of energy for various applications. So this is the basically as per some old data, this is a power scenario in India. Like coal is contributing 51.9%, lignite is 1.7%, gas approximate 6.3%, diesel 0.1%, and renewable is 11.7%. Similarly, these are the renewable energy scenario in India, like including hydro also. Now, if we are talking about pumping system, so basically what type of pumping systems are available? So first comes basically grid-based water pumping. In grid-based water pumping systems, centralized power plant produces and distributes electricity by power grid, and that electricity drives a pump. However, in case of solar photovoltaic based water pumping system, solar panel produce electricity and that electricity drives a pump. In the case of diesel generators, fuel driven engine produce rotation, and that rotation is transformed to electricity, which helps in driving the pump. Similarly, fuel based water pumping systems like fuel driven engine produce rotation, and that rotation directly drives a pump. And similarly, wind power based water pumping system, animal driven, earlier used an animal driven water pumping system, and a hydropower system. So what is the need of solar water pumping system? The major challenge faced by the farmers include the frequent power outage and the rising cost of diesel. Switching to solar water pumps not only helps the farmers, but it helps overcome some of their major challenges. It also helps the government to save a huge amount of money in power and diesel subsidies. So basically, solar water pumping system, how it works in India. Approximate by the end of 2023, approximate 3 lakhs 40,000 water pumping system has been installed throughout the country. So the solar water pumps comes under the off-grid PV schemes of Jawaharlal Nehru Solar Mission and are provided up to 30% capital subsidy and loans at a very genuine interest rates. When it comes to the states, Rajasthan has been a pioneering in promoting solar water pumps and offers an additional good subsidy and above the MNRE subsidy, which means the solar water pumps owner gets a sufficient good amount of subsidy in total. So this is basically a basic animation of solar water pumping system. You can see with the help of solar, these solar panels, sunlight is converted into the electricity, and that electricity goes through a power electronic converter which supplies to a water pump. So this water pump can be used to supply water directly to the fields, or this water can be stored in the overhead tank and later on it can be used. If we are comparing between solar and diesel power pump, like if we are saying investment point, solar water pumping system investment is higher, but however in diesel power pump investment is very low, and running cost of solar water pumping system is very negligible. However, in case of diesel it is pretty high. If we are seeing maintenance point of view, then solar water pumping system panel requires cleaning at a frequent interval. However, in diesel power pump, minor and major service of periodic overhauling which needs skilled labor. Anybody cannot do this. If we are talking about power system requirement, solar water pumping system approximate twice of the power of the pump power is required. However, in case of diesel, it is 4 times. If we are talking about hazardness, solar is green energy, it is pollution free and it is available unlimited in quantity. If we are talking about diesel, it is fire hazardous and it is polluted. If we are talking about logistic, there is no logistic is required in solar water pumping system. However, in case of diesel, logistic and storage is required. So this is some data. This is I have taken from MNRE. It is up to 2022. Basically, these are the some applications of solar water pumping system. Like solar water pumping can be used for irrigation and sprinklers also. Similarly, or solar pumping swimming pools, aerator mechanism in aqua farming, solar water fountain, domestic and municipal water supply, livestock fish tank, solar water heating system, RO system, civil, industrial and mining systems. So this is the basically a conventional solar water pumping system. So how much water does a solar water pumping system pumps? The daily water output of a solar pump depends on four factors like how much solar energy is available, what is the power of the solar panels that are used to change the solar energy into useful electricity, what is the total vertical distance that the water is pumped measured from the water level in the borehole to the level of water in the reservoir, how efficient the system is. These four factors decides how much water the solar water pumping system will pump. So basically, this is the configuration. These are the various configuration of solar water pumping system. Like it consists of solar generator, a tracking, non-tracking system, and there are various power conditioners which are being used in power water pumping system. And there are different types of motors like AC motor and DC motors which are being used for water pumping system. So I have in this talk I have targeted only one type of motor, that is synchronous reluctance motor. I will discuss in detail about synchronous reluctance motor, why I have chosen that synchronous reluctance motor. So basically in solar PV array we are always operating at maximum power point tracking. So this is the one important part of MPPT is important part of solar water pumping system. So basically MPPT is used for the extraction of maximum power available from the solar PV array, and there are several MPPT techniques are available like hill climbing, incremental conductance, fractional open circuit, fractional short circuit, fuzzy logic, neural network, and many more. So in this work we have only used the very simplest incremental conductance MPPT technique. There is nothing new. We have used already available MPPT technique. So basically the aspects of MPPT techniques like complexity, how many sensors are required, convergence speed, cost, range of effectiveness, implementation hardware, and popularity. So now there are several MPPT techniques are available which are using less number of sensors, which is responsible for reducing the complexity. Now MPPT techniques has been combined with the help with the AI also to reduce the complexity burden also. So I told that I have chosen synchronous reluctance motor for this work. Why I have chosen synchronous reluctance motor? There are several motors are available. So I have chosen synchronous reluctance motor because synchronous reluctance motor basically induction motor outside and innovation inside. It means innovation inside means you can use the same stator as is being used in the induction motor. However, you need to change some. You need to do something with the rotor part. In synchronous reluctance motor, there is nothing on the rotor. There is no winding, no magnet, which is responsible for the reduction in the losses of the motor. If we are talking about induction motor is widely used for water pumping system, but the major disadvantage of with induction motor is, okay, the efficiency of induction motor is not as much as good, and the control circuit is very complex for induction motor. So if you are talking about synchronous reluctance motor, you can see synchronous reluctance motor is having some this type of stator. There is nothing on the stator. This is on the punched. There are only some slots on the rotor. However, if you are talking about other motors like PM motors and induction motors, there are some bindings or permanent magnets. So which is responsible for increasing the cost of motor, and there are some losses also. So in this motor there is nothing on the rotor. That's why we have chosen this motor for water pumping application. So this is the exploded view of synchronous reluctance motor. This is consists of stator frame, rotor, terminal box, terminal board, screws, and etc. all the parts. So basically, a synchronous reactance motor has the same structure as that of a salient pole synchronous motor, except that it does not have a field winding on the rotor. When it is not having field winding on the rotor, joule loss is almost zero. So because of that, the efficiency of this motor is pretty good. Speed of this motor varied by controlling stator voltage and frequency, and there is no slip. There is a synchronous operation without magnet, and configuration here has no starting cage. So this motor is can only be run with the help of inverter power. This is you can consider a disadvantage, because induction motor you can start without any controller. So this is basically this is the cross section of a synchronous reactance motor. You can see this is the stator and stator winding, and this is the rotor. Rotor is having some slots. There is no magnet, no squirrel cage on the rotor. Because of that, there is no joule losses in the rotor. Similar stator as induction motor, same power frame ratio as induction motor, and it requires an electronic controller for running this motor. So if we are talking about, if we are saying, if we are looking for the difference between permanent magnet and synchronous reactance motor, there is no winding, no cage, and no magnet in synchronous reactance motor. So in the recently, this motor has gained very importance by the researchers, and even in industries also. This motor has been a subject of interest for many variable speed industrial applications. There are no winding, magnets, or cage in the rotor. The rotor of synchronous reactance motor are cheaper and lighter than the rotor of induction machine, and permanent magnet synchronous reactance motor with the same size. Because there is nothing on the rotor temperature is very low. The torque ampere ratio is independent of rotor temperature, unlike that of both induction motor and permanent magnet synchronous machines. The stator of synchronous reactance motor and the inverters to supply them are identical to those of both induction motor and PMSM. And speed control without encoders. Basically, I have targeted without encoder because these submersible pumps are installed hundreds of feet below the ground. And if you are using encoder, you need to lay long cable. And that cable may break, that signal may then lose its strength. You will not be efficiently calculate the position of that motor. So I have chosen the sensorless control. Sensorless control is much easier in this motor. The main disadvantage, power factor of synchronous reactance motor is not as good as induction motor and PMSM. So because of this required a high inverter rating. But the efficiency of this motor is pretty good. So inverter rating is high required, but solar panel requirement is reduced. Efficiency of this motor is better than induction motor and inferior to that of PMSM of say power rating. However, in synchronous reactance motor, an amount of low-cost permanent magnet is inserted in the rotor to further improve its torque density and power factor and efficiency also. This type of machine is called a PM-assisted synchronous reactance motor. So it is having the similar winding as induction motor, like distributing winding. However, synchronous reactance motor with flex barrier for maximization of magnetic anisotropy. This is the basically synchronous reactance motor coupled with DC motor. This is coupled with DC motor, and these are the internal structure of synchronous. Like this is the rotor lamination, single rotor lamination, and we are making the rotor by punching them together. The applications of asynchronous reactance motor, these motors are being used pumps, for conveyors, for or proportioning devices in synthetic fiber manufacturing industries, for positioning of control rods in nuclear reactors, in synchronized textile drives, in wrapping and folding machines, for processing of continuous sheet or film material, in constant speed applications such as recording instrument, control apparatus, regulators, timing devices, turntable, and so on, like metering pumps, wrapping and folding machines, synthetic fiber manufacturing equipments, pressure booster system, pumps and conveyors, electrical vehicles also. Now, synchronous reactance motor for electrical vehicle is a very hot area of research. So basically, this is the history of synchronous reactance motor, how it has been developed. So in earlier 90s, the rotor has been developed by removing some portion of this structure. So these iron segments have been removed, and this has been used for synchronous reluctance motor. In the later on in recent development, this type of rotor comes into picture. This is a simple salient pole rotor with axially laminated anisotropy. So this is basically comparison between synchronous reluctance motor and induction motor. You can see outer body is for induction motor, inner side is synchronous reluctance motor. Both are from same power rating. You can see same power. There is a small motor is required, same size power. You can, if you are using the same size synchronous inverter, you can obtain higher power. You can say induction motor on the outside, innovation inside, and efficiency of this motor is pretty good. So this is basically a difference from rotor structure point of view. Synchronous reluctance motor is very powerful yet highly compact motor up to 2 frame size smaller than the conventional motor. Variant codes and mechanical construction based on the proven cast iron process and performance motors. There is no moving magnet and no cage. Competitive product offering compared to traditional or other new technologies. High reliability through lower bearing temperature. Since there is no squirrel cage or no magnet on the rotor, the efficiency of this motor is quite good. You can see in this diagram, if we are talking about induction motor at lower speed, the efficiency of induction motor is not good. However, in case of synchronous reluctance motor, the efficiency of this motor is almost constant throughout the speed range. The cost of induction motor is lower in comparison of PM motor and induction motor. So basically, the rotor of synchronous reluctance motor are cheaper and lighter than the rotors of induction machines and permanent magnet synchronous machines with the same size. The power factor of synchronous reluctance motor is poor compared to both induction motor and permanent magnet synchronous machine. The efficiency of synchronous reluctance motor is much better than of induction motor, is inferior to PMSM. The stator of SYRM and the inverters to supply them are identical. So these are the different types of rotor which has been used for synchronous reluctance motor, like simple salient pole, axially laminated and transversely laminated rotor. So this is basically simple salient pole rotor. Is the first possibility is made by removing some iron material from each rotor in the transversal region. However, in ALA axially laminated rotor, the laminations are suitably shaped at each pole and insulated from each other using electrically and magnetically passive materials, and the resulting stacks are connected through pole holders to the central region to which the shaft is connected. So, and similarly in transversely laminated rotor, TLA rotor, the laminations are punched in a traditional way. Thin ribs are left when punching. Thus, the various rotor segments are connected to each other by these ribs. So this is basically a comparison between TLA and ALA rotor. I am skipping these parts because this is more into the design of motor. So now I am coming to the basically water pumping system topologies. Basically, there are many motors are available for water pumping system, like DC motor. The major advantage with DC motor, there is you can directly connect DC motor with solar panels. There is one power electronic conversion stage is avoided. However, this motor is not preferred because of the frequent maintenance requirement. In case of induction motor is more reliable and maintenance free as compared to DC motor, but and it is suitable for even in hazardous and contaminated areas. The main disadvantage, it requires complex control. And next, BLDC motor. BLDC motor is the most popular motor, and now it is the only one motor which is being used for water pumping application, electrical appliance, electrical vehicle also. So this motor having low inertia and friction. It is having much higher speed than other motors. Efficiency of this motor is very high. And similarly, switch reluctance motor, the disadvantage with switch reluctance motor, a very high torque ripple and acoustic noise problems. This motor has not been received much attention for water pumping application. Similarly, for synchronous reluctance motors, uh, this motor also has not received much attention for water pumping. PMSM, it is usefulness in submersible installation because of its higher efficiency as compared to induction motor. Better choice for global efficiency optimization for water pumping system, but major disadvantage, it used permanent magnet. There is a chance of demagnetization in high temperature area. These are the various topologies for water pumping system for all the motors. Like one is position sensorless and other one is position sensorless based motor types. And in both standalone and grid connected PV system, and in standalone and single stage and double stage power conversion system, and grid connected unidirectional and bidirectional systems. For this is the very first topology for synchronous reluctance motor based water pumping system. It is a standalone two-stage solar water pumping system based on synchronous reluctance motor drive. So this is basically solar PV array. It is connected to the motor through a boost converter and a voltage source inverter. So this DC-DC converter basically is responsible for the MPPT of this PV array, and this basically this DC power is being used to supply power to the motor with the help of this voltage source converter. So these are the some parameters. Like for this application, we have chosen approximate 3.9 kilowatt MPP solar PV array, and the motor which we have selected for this water pumping application is at 80 volt, 3000 RPM, and 4 kilowatt. This is the basically a design of boost converter. For this boost converter, we have calculated the inductance for boost converter, that is approximate 5 millihenry, and for if we are talking about capacitor, we have chosen a 550 microfarad capacitor for this application. This is a design of BSI. The switch voltage rating of IGBT for BSI is approximate 900 volt, and current is 9 ampere. So required BA rating of BSI is approximate 8.1 kV. The control of system is divided into two parts, like MPPT and control of synchronous reluctance motor. So for MPPT, we have chosen the incremental conductance based MPPT technique. This is the simplest type of MPPT technique which are being used for solar power optimization, and this technique is widely used because of its simplicity. So this is the speed sensorless control of synchronous reluctance motor with constant D-axis current control. Basically, we are not using any encoder or any sensor for calculating the speed of the motor. We are estimating the motor speed with the help of motor current and DC voltage. With the help of these motor current and DC voltage, with speed sensorless control algorithm, we are estimating the motor position, and that position is transformed into the encoder speed. So this is conventional speed sensorless control algorithm which has been used for the induction motor. Same technique we have tried to use with synchronous reluctance motor, and we found that same technique worked for both the motors. This is basically whenever we are designing the rotor of this motor, there two inductance comes into the picture, D axis and Q axis inductance. Because of the cross saturation, and the D axis inductance is changing with the motor speed. So we have estimated the D axis inductance in real time for this application. The control of motor is divided into two parts, like estimation of reference speed. So basically, according to the affinity law, one component of reference speed is estimated with the help of rated speed and available solar power. The reference speed is the component of available solar power. As solar power changes, the reference speed changes, and when reference speed is changing, actual motor speed is following the reference speed. So basically, the reference speed can be calculated with the help of these two components. Second part is control of synchronous reluctance motor. So we have used simple field oriented control, vector control for synchronous reluctance motor. This is the simplest control. Basically, for induction motor, we can do BYF control and vector control and director control. So here we have used vector control and IYF control. Where we have used IYF in place of BYF, we have used IYF control, and where we have used IYF control and why we have used IYF control, I will explain. So this is the basically hardware prototype for solar water pumping system. This is the synchronous reluctance motor of 4 kilowatt, and this is coupled with DC motor. The DC motor, basically this is coupled with DC motor to emulate the characteristics of water pump. We have not used actual water pump. We have emulated the characteristics of water pump, and this is a solar PV emulator, and these are the various power electronics part. If you are talking experimental results like MPPT techniques, so these are the MPPT characteristics at 1000 watt per meter square and 500 watt per meter square. So in the both the cases, you can see MPPT is almost 100%. And these are the starting response. So I was talking about IYF control. So generally in case of motor, when we are starting the motor, it takes starting current is pretty high. That can cause damage to the motor. So here we have used IYF control. So during IYF control, we are slowly increasing the D-axis current until and during starting we are disabling the MPPT. We are starting the motor without MPPT. So we are in IYFO and without MPPT. Motor is starting, and you can see the starting current is very small. The starting current remains in limit in this IYF mode. So you can say when MPPT disabled, the current is as much, and when MPPT enabled, it obtains the rated current and motor rotates at its rated speed, which is 3000 rpm. This is the zoomed version. The earlier starting current is 0. When we start at this point, when we starting the motor, it's slowly increase the current. The motor operates without any danger. There is no chance of any damage to the motor. This is the steady state response during when motor obtained steady states. It rotates at 3000 rpm. You can see the different parameters like PV voltage, PV current, PV power, and DC voltage. Similarly, three-phase motor currents and motor estimated speeds. These are some internal parameters like alpha beta axis fluxes and overall fluxes, and this is estimated position. Similarly, these are the internal like estimated torque, flux, motor current, and speed. This is the dynamic response. When there is an increase in the solar insolation, there is a decrease in the solar insolation from 1000 watt per meter square to 500 watt per meter square. So when solar insolation decreases, available solar power is decreases. When solar power decreases, I told you that reference speed is a component of available solar PV power. So when solar insolation decreases, available power decreases. Similarly, following reference speed decreases and motor starts rotating at as per the reference speed. Similarly, when there is a increase in the solar insolation, available power increases, and when available power increases, reference speed changes, and accordingly motor speed changes. So this is basically, earlier I was talking about constant D-axis. Now this is for adaptive D-axis. Adaptive D-axis current control means D-axis current is changing as per the available power. So this is the basically MPPT performance for 1000 watt per meter square and 500 watt per meter square. You can see for both conditions MPPT is almost 100%. And if we are talking about starting response, you can see here also motor starting current are in limit. So this is basically controlled starting, and we have patented this starting also. We are having patent in this area. And earlier we have disabled the MPPT, and when motor states some steady state speed, then MPPT is enabled, which results in the safe starting of the motor. You can see this is the starting, this is IYF starting, and this is constant D-axis current control, and then adaptive D-axis current control. These are the steady state response when there is a solar insolation is uniform. In steady state behavior, motor rotates as per the available PV power. And when we are talking about dynamic response, when solar insolation is decreasing from 1000 to 500 watt per meter square, accordingly other parameters are changing. Motor is rotating at lesser speed, and because of that the current is reduced. Similarly, when solar insolation is increased, the motor speed is increased. You can see solar insolation is increased, motor reference speed is changing, and motor estimated speed is exactly following the reference speed. Now earlier we are talking about two-stage solar water pumping system. Now it comes to single stage solar water pumping system. In single stage, there is one power conversion stage is avoided. There is no DC-DC converter. MPPT and motor control both are performed with the help of only one BSI. The advantage of this technique, there is one power electronic conversion stage is avoided because of this, that the size and weight of the power electronic controller reduces, but the disadvantage, there is some fluctuations in DC link voltage because there is no DC-DC converter. So this is the same speedless sensorless control which we have used for this single stage. This is the characteristic for MPPT for both 1500 watt per meter square. You can see for both the scenarios the MPPT is almost 100%, and this is the steady state response. In single stage, you can see there is some there is some ripples in the PV voltage because of there is no DC-DC converter. So earlier it is open loop starting, then when it reaches some steady state, then MPPT is disabled or motor starts working in closed loop mode. This is the dynamic response for decrease in solar radiance and increase in solar radiance. As solar insolation is decreasing or increasing, the motor is exactly following the same pattern. If it is increasing, motor is rotating at the maximum speed, and when it is reducing, the motor correspondingly motor speeds change. This is for another type of control which has been used for this single stage, like MPPT is almost 100%, or the starting and steady state response is almost similar to earlier one, and this dynamic response is also same as for earlier control. Now these are for the you can say standalone water pumping system. There is no grid or no battery, nothing else. Now if we are talking about grid connected system, so first we are talking about single phase grid interface unidirectional two-stage solar water pumping system for water pumping. So you can see there is a PV array which is connected to a DC-DC converter, and there is a single this system is connected to a single phase grid also. There is a diode with rectifier, there is a boost converter. Any problem? Is there any problem?
Yes, please,
Is there any problem?
participants, unmute yourself, please. Yes, remaining participants, please unmute yourself.
क्योंकि जिंदगी में हमें आगे बढ़ना है और टॉप पे
Madam, can you mute these persons?
Yes, sir.
ये तो अपने इंडियन जैसा सोचता है.
Now this is basically a grid interface unidirectional two-stage water pumping system. So grid and PV array both are interlinked with the help of a DC link, and this is basically this, since we have connected grid with the system, so there is a unidirectional power flow control mechanism is also required. So this is basically unit template based control algorithm has been used for generating the pulse for grid side boost converter. So the system is basically working in three modes. Like in first mode, when there is only PV power is available. In mode 2, when there is no PV power available, the system works with the help of grid only. In mode 3, when solar PV and grid supply both are available. So the parameters for this system, we have chosen a approximate 2 kilowatt PV array, and motor rating is 1.5 kilowatt. The motor speed is 1800 rpm. So this is the basically design of grid side boost converter. Basically, in grid side boost converter, we have calculated the inductance, capacitance, etc. So basically, if you are talking about mode 1, when there is PV power available, there is no grid available. In that case, the system works as the two-stage standalone system. So you can see this is MPPT characteristics at 1000 watt per meter square and 500 watt per meter square. So in both the cases, the MPPT is 100%. Available power in 1000 watt per meter square approximate 2 kilowatt, and at 500 it is approximate 1000 watt. If you are talking about starting at steady state, it is similar to the standalone system. Because there is no grid, the system is behaving like a standalone two-stage water pumping system. Similarly for dynamic response, if we are talking about grid connected, when there is no PV power, only grid is available. In that case, the system is water pumping system is working with the help of grid supply only, and in the grid supply mode, also safe starting is maintained. And you can see when we are running this motor with the help of grid only, The current ESD is only 2.5%, which is as per IEEE 519 standard. IEEE 519 standard says the current ESD should be less than 5%. It is as per IEEE 519 standard. So when we are talking about mode 3, when PV power is also available and grid supplies are also available. So when both supplies are available, in that case, the control of the system has been designed in such a way the maximum power is taking from PV source, because PV power is freely available. The control is developed in such a way the maximum power is taking in from PV. You can see at approximate 550 watt per meter square, it is taking approximate 1 kilowatt power from solar, 1 kilowatt power from solar, and deficit power to run the motor at rated speed is taken from the grid. So this is basically 50% power sharing. 50% power is being taken from the PV array and 50% power is being taken from the grid. So this is the basically dynamic performance in mode 3. You can see when solar insolation is 1000 watt per meter square. When solar insolation is 1000 watt per meter square, the motor pump is running with the help of PV power only. Grid current is almost zero at this point. When solar insolation reduces from 1000 to 700 watt per meter square, at that point PV power reduces and the power required to run the motor at rated speed is reduces. So the deficit power is taken from the grid. You can see when solar insolation reduces, the deficit power is taken from the grid to run the motor at rated speed. Similarly, when we are running this mode, when solar insolation is 700 watt per meter square, the system is taking power from PV source as well as grid to run the motor at rated speed. When solar insolation increases from 700 to 1000 watt per meter square, in that case, grid current becomes almost zero. All the power has been drawn with the help of with PV source only. Now, similarly, if we are earlier we are talking two stage, now we are talking single stage grid interface in reactional water pumping system. So the system is working similarly as the previous system, but only the power one DC-DC converter has been avoided. So this system is also working in three modes: when there is only PV power, when there is only grid power, and when both the powers are available. If you are talking about MPPT, it is almost similar for 1000 watt per meter square and 500 watt per meter square. In both the cases, MPPT is almost more than 95%. And if we are talking about a steady state response, the motor starting current remains in the safe limit to avoid any damage to the motor, and motor is running perfectly fine with only PV power. If we are talking about mode 2, there is no PV power, only grid supply is available. In that case, the current ESD is less than 5% as per IEEE 519. A motor is taking 100% power from the grid because there is no PV power available, and safe starting is also enabled in this mode also. If we are talking about mode 3, in this mode also 50% power is taken from the grid, and last 50% power is taken from the solar. So 50-50 power sharing mode has been depicted in this result. If we are talking about similarly dynamic performance, when solar insolation is 1000 watt per meter square, grid current is almost zero. When solar insolation is reduces from 1000 to 500, it start taking power from the grid to run the motor at rated speed. Now it comes to the single phase grid integrated bidirectional. Earlier we were talking about unidirectional power flow system. Now we are talking about bidirectional. In unidirectional, you cannot inject the excess PV power to the grid. However, in case of bidirectional, if, as everybody knows, water pumping is not required all the time. So in case when there is excess solar power is available, that excess solar power is being injected into the grid, which results in the financial benefit to the users. So basically, this is a front-end converter, and this system is like standalone system. So this basically this scheme is for bidirectional power flow control. With the help of this control scheme, we are providing the pulses for this front-end converter. And earlier system was working in 3 modes. Similarly, this system is working in 4 modes. Mode 1, when there is only PV power available. Mode 2, when there is no power available from PV array, it is working with the help of grid only. Mode 3, when solar PV and grid supply both are available. And mode 4, when the solar PV array power is more than the required rating of the water pumping system, then this mode works. So the rating is for this system we have taken a 4 kilowatt PV array and 1.5 kilowatt motor. You can say this solar PV array rating is pretty high than the motor. So you can see there are 3 MPPT characteristics in this mode. Earlier there are only 1 or 2. So you can see at 500 watt per meter square the PV rating is approximate 2 kilowatt, so which is sufficient to run the motor as rated speed. So in that case the system is working at MPPT and the required power is taking from PV. So when solar insolation is increased either 750 or 1000 watt per meter square, in that case maximum power is 2 kilowatt. So there is no need of MPPT. The system is working in off MPPT mode. If we are talking about starting response, in this mode also the starting currents remains in safe limit and motor starts safely and rotate its rated speed to provide the 100% rated water discharge. This is the dynamic response. And if you are talking about mode 2, when there is only grid supply, the safe starting is also enabled in this mode and the current TSD approximate 1.6%, which is as per IEEE 519 standard. Now if we are talking about mode 3 is also similar. If 50% power sharing is enabled, 50% is power taking it from the solar PV array and rest deficit 50% power is taking from the grid to run the motor at its rated speed. If we are talking about mode 3, it is also when solar insolation is increasing from decreasing from 5500 to 200 watt per meter square. In that, when solar insolation is 500, the power drawn 100% power is being taken from the PV array and grid current is almost zero. When solar insolation decreases, PV power decreases and deficit PV power is taken from the grid to run the motor at rated speed. So now if we are talking about mode 4, when there is solar power, installed solar PV capacity is more than the required rating of motor. In that case, you can see at 1000 watt per meter square, PV power is approximate 4 kilowatt. However, motor rating is only 1.5 kilowatt. So you can see there is a grid voltage and grid current are out of phase. This out of phase means power is being injected to the grid. You can see only 1.2 kilowatt power is required to run the motor at rated speed, and rest 2 kilowatt power is being approximate. You can say 1.76 kilowatt power is being injected into the grid, which results in the financial benefit to the farmers or users. Similarly, if you are talking about dynamic performance in this mode, when solar PV array capacity is more than the required rating of motor, in that case, when you can see when solar insolation is 800 watt per meter square, in that case the power is being injected into the grid, or when solar insolation is reduces from 800 to 300, in that case mode 4 to mode 3 change occurs, and in that case motor is taking some power from PV and deficit power from the grid to run the motor at rated speed. This is basically 2 stage. Now this is for single stage. Single stage is almost similar, only DC-DC power converter is avoided in this stage. The results in almost similar in this mode also. So now I am coming to the 3 phase. If you are talking about for higher rating motors, in that case 3 phase grid integrated bidirectional double stage solar PV array fed water pumping system has been used. In that case there is 3 phase grid connected through a voltage source converter through the DC link capacitor to the pump. So in that, this is the basically bidirectional power flow control scheme for this system. This system also works in 4 mode, like mode 1 when there is only PV power, mode 2 when there is only grid, mode 3 when PV and grid both are available, and mode 4 when the solar PV array power is more than the required rating of water pumping system. So for this system we have taken a solar PV array of approximate 8 kilowatt and motor rating is 4 kilowatt. In this case when solar insolation is approximate 500 watt per meter square. So at 500 it is MPPT power is approximate 4 kilowatt, which is sufficient to run the motor at rated speed. When solar insolation is increased, because in mode 1 there is no grid, so there is no grid available, so we are not able to inject the power into the grid. So in that case, the system will work in off MPPT mode. This is the starting and steady state response in mode 1, where there is only PV power available. So in that case, safe starting is enabled and motor runs at rated speed. You can see earlier MPPT is disabled, and after reaching some steady state speed, the MPPT is enabled. So for dynamic response also, when solar insolation either increases or decreases, correspondingly motor speed increases or decreases as the solar power changes. If we are talking about mode 2, when there is only grid supply available, in that case also motor runs at rated speed, providing the rated water discharge from the pump and maintaining the power quality parameter as per IEEE 519 standard. If we are talking about mode 3, in mode 3 basically power sharing is done between the grid and PV. You can see the motor rating is 4 kilowatts. You can see 2 kilowatt power is taking from the solar PV array, and rest deficit 2 kilowatt power is taking from the grid, and maintaining the power quality parameter as per IEEE 519 standard. Current TSD is approximate 3.7%. So if you are talking about dynamic performance, so earlier when when PV power is sufficient to drive the motor, in that case grid current is 0. When PV power reduces, the rest required power to run the motor at rated speed is taken from the grid supply. If we are talking about mode 4, when solar installed capacity is more than the required rating of the motor. So at 1000 watt per meter square, the maximum power is approximate 8 kilowatt. However, motor rating is only 4 kilowatt. So 4 kilowatt power is required to run the motor at rated speed, and rest for approximate 4 kilowatt power is being injected into the grid. So this current reverse, this out of phase shows the key power is being injected into the grid. Similarly, for dynamic performance in this mode, when motor is running, once available solar insolation is approximate 800 watt per meter square. At 800 watt per meter square, the power available is sufficient to drive the motor at rated speed, and deficit power is being injected into the grid. When solar insolation reduces from 800 watt to 400 watt per meter square, in that case only PV power is not available to run the motor at rated speed. In that case, deficit power is taken from the grid, maintaining the power quality as per IEEE 519 standard. So this is basically another topology for grid integrated bidirectional single stage. In this case, the one power conversion stage is avoided to reduce the complexity and size and weight of the system. This system also works in 4 mode, similar to earlier one, like mode 1 when there is only PV power, mode 2 when there is only grid power, mode 3 when solar PV power and grid supply available. Similarly, mode 4 when grid power is being injected into the grid. For this system, we have taken a 4 kilowatt system. And this is the MPPT and off MPPT in mode 1 when there is only PV power available. And this is the starting and steady state response, like to similar one, previous one for starting and steady state. And these are the dynamic response when solar insolation either decreasing or increasing. And this is for mode 2 when there is no PV power. All the power is taken from the grid, maintaining the power quality parameters as per IEEE 519 standard. This is mode 3 when basically power sharing mode. In that case, power is being shared between grid and PV. And this is a dynamic response on mode 3 when solar insolation is either increasing or decreasing. Because mode 3 is power sharing mode, so either solar insolation is if solar insolation is decreasing, in that case deficit power is taken from the grid. If solar insolation is increasing, in that case excess power is being injected into the grid. So these are the characteristics in mode 4 when excess solar power is available, then the required motor power rating. In that case, the excess solar power is being injected into the grid. This is the dynamic performance in mode 4. So this is all about solar water pumping topologies, which has been developed, and some topologies have been patented. Out of these five, out of these all technologies, 3 have been patented and 3 patents have been granted for these topologies. One is in stage, application stage, that we are waiting for the further processing. Thanks. Any question?
Thank you so much, sir.
Hello, sir.
Hello, madam.
Have you completed your complete PPT?
Yes, ma'am.
Actually, my screen got freeze, so I cannot able to see the screen. That's why.
Okay. I finished. Is there any question?
Okay,
We can
okay.
take some questions.
Yeah, sir. Any participants want to ask any of the questions? Any participants, please? Any questions?
If there is no
Sir?
question, we can close.
Yes, sir. Yes. So, thank you, sir. Your presentation was very informative. You have shown various data and insights of the topic.
Thank you, madam.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you, madam. Thank you.
Okay, thank you, participants. So, I think you must have filled the attendance link. I have shared in the chat box already.
Yes,
All
ma'am.
the 2 sessions attendance link.
Yes, ma'am. Already filled.
Okay, fine. So, thank you, all of you.
Thank you, ma'am. Good day.
Okay, ma'am. Thank you. Session is completed. Thank you, all of you.
Thank you, ma'am.